Okay, so good morning, ladies and gentlemen. And yes, in today's live stream, I will be solving some more greedy problems. And yes, I would like to recommend you all to, watch the previous video about greedy, which, explains how to solve the question 10382 watering grass problem. And this problem is based on a classical problem, which is lead code question number 45, jump game 2. Basically, in these two questions, you will be understanding how to solve the interval problems. If you haven't watched the previous video, I recommend you to watch the video. This question is pretty amazing if you haven't been introduced to greedy yet. And yes, it's really informative video. It's just an hour or so. And yes, I hope that you guys will watch the video. So yes, let me open my VS Code. Yeah. Okay. So this was the code for the 10382 problem UVA. And please, guys, just at least watch the video. Spend some time. Don't means I don't expect you to watch the video. Just by sitting ideally on a couch, or by laying on a bed or something. You have to take your keyboard, you have to take your monitor, you have to type in the code. And yes, that's how you will understand what's going on. You have to experiment with the idea which is being discussed in the video. And yes, you have to first of all think what's going on. Try to solve the problem by yourself. If you don't come up with a solution, or if you come up with a solution, try to check if there's a better approach, and indeed try to get the knowledge about the greedy principles. Don't try to mug up the code. It just won't benefit you in the long run. So yeah, this is the next problem which we'll be solving, and the title is UVA double one 292 Dragon of Blue Water. Okay, here's the hint. And before reading this problem, I would like to, before reading the solution and the hints, I would like to uh, read the problem by myself. 11292. Yes. Okay. This seems an interesting problem. Okay. The Dragon of Blue Water. Once upon a time in the kingdom of Blue Water, a minor nuisance turned into a major problem. The shores of Relau Creek in central Blue Water had always been a prime breeding ground for geese. Due to the lack of predators, the geese population was out of control. The people of Blue Water mostly kept clear of the geese. Occasionally, a good geese would attack one of the people and perhaps bite off the finger or two, but in general, the people tolerated the geese as a minor nuisance. One day, a freak mutation occurred, and one of the geese spawned a multi-head fire-breathing dragon. Okay. When the dragon grew up, he threatened to burn the kingdom of Blue Water to a crisp. Blue Water had a major problem now. The king was alarmed and called on his knights to slay the dragon and save the kingdom. The knights explained, to slay the dragon, we must chop off all of its heads. Each knight can chop off one of the dragon's head. The head of the dragon are of different sizes. In order to chop off a head, a knight must be at least as tall as the diameter of the head. Okay, a knight must be as tall as the diameter of the head. Okay. The Knights Union demands that for chopping off a head, a knight must be paid a wage equal to one gold coin for each centimeter of the knight's height. Fantastic. Would there be enough knights to defeat a dragon? The king called on his advisors to help him decide how many and which knights to hire. After having lost a lot of his money building Mere Park, the king wanted to minimize the expense of slaying the dragon. As one of the advisors, your job is to help the king. You took it very seriously. If you failed, you and the whole kingdom would be burned to a crisp. Okay, so yeah, I actually don't know why these questions of UVA have some unnecessary information. I don't think that this is necessary, but yeah, let's go through it. A Canadian goose, Branta, Branta canadensis. Okay, light brown wings, white undertail, brown legs and webbed feet, light tan to cream breast feathers. Okay, white chin strap. Wow, brown bill and black eye. So yeah, input. The input contains several test cases. The first line of each test case contains two integers between 1 and 20,000 inclusive, indicating the number n of heads that the dragon has, and the number m of knights in the kingdom. The next n lines contain an integer and give the diameters of the dragon's head in centimeters. Okay. The following M lines each contain an integer and specify the heights of the knights of blue water, also in centimeters. The last test case is followed by a line containing 0, 0. For each test case, output a line containing the minimum number of gold coins that the king needs to pay to slay the dragon. If it is not possible for the Knights of Blue Water to slay the dragon, output the line Blue Water is doomed. Fantastic, man. I love CP, man. I love CP. Yeah. So let's see what's going on. We'll open our journal. And yes, what's the first test case? The first test case is 2 and 3. This is the, I guess, what is this? Okay. Let me check again. Yeah, the number of heads. This is the number of heads, and this is the number of knights. So this is actually n, this is m. The next two lines should represent the diameter of the head of the dragon. So yeah, then next two lines are 5, comma 4. Yeah, and the next three lines 7, 8, 4 is the height of the the what can we say? The knights are pretty short. I would say 7 centimeters is not that tall. So 7, 8, 4. Fantastic. So we have to minimize the what shall we say? We have to minimize the expenses, doesn't it? So okay, let's say a drag. Let's say there's a height of, let's say, height 6. So it can kill a dragon with um with a dragon which has diameter less than or equal to 6, isn't it? But ideally, we don't want to exceed our expenses. So ideally, what should be the case? Ideally, if uh, x is the diameter of the head of the monster or the dragon, then y should be uh yeah then y should be the height of the knight, isn't it? And y y minus x should be greater than equal to 0 and should be minimum and should be minimum, isn't it? So let's say uh, now as we have a dragon whose diameter of the head is 4. So we would like to find a number which is greater than equal to 4. Yeah, greater than equal to 4. The difference between these two, the smaller the difference between these two numbers, the better it is, because we are trying to minimize the expense. So I would like to ask, for killing this dragon, which soldier or knight would you like to assign? So you may ask, shall I assign a knight of height 7? Yeah, you can. Shall I assign a height? A knight with whose height is 8 or 4? Yeah, you can assign any of these knights. But I would like to ask, is there even a point in assigning a knight whose height is 7 centimeters to kill a dragon whose height is, let's say, what can we say? Whose height is, let's say, 4. Yeah. Now imagine if 8 was not in the test case. Instead of it, there was a 3. So let's say there are, what I would like to explain is that there would be two problems if I assign uh, a knight of 7 centimeters to a dragon whose head is of diameter 4. First of all, our expense would increase because even though we have a knight whose height is indeed equal to 4 centimeter, and as 4 is nearer to 4 than 7, then our expenses are increasing, and this is not the main issue. One more issue which we are facing, which we will face by doing this is that for killing the dragon whose head is of diameter 5 centimeters, we have no other soldiers left, isn't it? So by picking a tall soldier to kill a short dragon, it's of no use. It won't, it's decreasing our future feasibility, isn't it? So our main aim is to find a y which is indeed greater than equal to x, and this y should be minimum, isn't it? So this is a standard greedy problem. So yes, you will first of all sort the uh, n. What can you say? The n heads first. We would also sort the yeah. We would also sort the height m heights. So and we will use a two pointer approach. So can I kill this dragon whose head is a diameter 4 centimeter with this knight? And the answer is yes. If the answer is yes, move the pointer. And yes, as we are, assigning this knight to this dragon head, we will be also shifting the pointer, which is pointing to the heights of the soldier. Now, can I, kill the dragon whose head's diameter is 5 centimeter with a soldier or knight whose height is 7 centimeter? And the answer is yes. Okay. Now let's say now as you reach the end of the dragon head, the answer would be 4 comma 7. Now what do you have to? Yeah, the answer would be 4 plus 7, the minimum expense. Let's say if there was a dragon whose height is whose head is of diameter 9, and now here we are. Can a soldier of height 8 centimeters kill a dragon whose head is of diameter 9? And the answer is no. So we have reached the end of the knights, but we haven't killed all the heads of the dragons yet. So the answer would be yeah. Blue water is doomed. We have to output this string. So yeah, that's okay. So that's the simple program which we have to write. And yes, let's check in the input again. 2 comma 3, 2 comma 1. Okay. And here the answer should be blue water is doomed. Why? Because I can kill one knight can kill a what can we say one of the dragon, but there are no more knights left. So yeah. What the question number is 11292. UVA 11292. We have to input first n comma m. We will have an infinite while loop. Then we will take the input n comma m. If both of these are 0, we simply break. And if not, then we'll take the input for. Are there any constraints about the head and the height? And the answer is no. I would like to assume that, yeah, contain an integer. Okay. So first of all, we are taking the input head head diameter. Okay. Head diameter I and height. Yes. I would like to write a separate function to get min cost. Okay, so we will be having head diameter and height as the two parameters. If let's say if head diameter is if head diameter dot size is greater than height dot size, that means there are not enough knights to kill all the heads. So yeah, I can simply return -1 here itself. And then I would like to sort head diameter dot begin, head diameter dot end. I will do the same for height. Yeah. And now we will have IND1, which points to 0, and IND2, which points to 0 again, while IND1 is smaller than head diameter dot size, and IND2, which should be smaller than height dot um of height dot size. Okay, so if head diameter dot IND1 is smaller than equal to height of IND2, we will kill the dragon head, and hence IND1 plus plus IND2 plus plus. Else we won't be killing dragon, and we will realize that mm, we have to only shift the pointer to. Now one thing which I would like to add is that, let's say you're seeing two statements, or two lines of code which are in both if and else statement. So you can delete them both from both of the statements, and you can simply write here IND2 plus plus. Actually, this doesn't make the code more readable, but it looks kind of professional. So yeah, this is valid. This and the previous statement which I had written is exactly the same. Now let's say if IND1 is equal to head diameter dot size, which means we have killed all the monsters. Yeah, and we were also expenses. Expenses are initially 0. If I have killed the dragon head, then I would like to add the expense or the height of the particular soldier in my expense. I've killed all the monsters and will simply return expenses. If I haven't killed all the monster, then I will simply return minus. So yeah, int min cost is equals to get min cost, head diameter, height, sorry. If min cost is equals to -1, then we will output this string blue water is doomed. Else, we will simply print the minimum cost. Let's check if our code is right. 11292. Okay. Yeah, yeah. Actually, I had create an array of size m for n for height, which is not true. So yes, blue water is doomed. And 11. Yeah, as expected. Let's see if our code is correct. Yes, we got an AC, and yes, this is a basic greedy problem. And let's read the theory. Yeah. Problem description. There are n dragons. There are n dragon heads and m knights, both in the range 1 to 20,000. Each dragon head has a diameter and each knight has a height. A dragon head with diameter d can be chopped off by a knight with height h if d is smaller than equal to h. A knight can only chop off one dragon head. Given a list of diameters of the dragon heads and a list of heights of the knights, is it possible to chop off all the dragon heads? If yes, what is the minimum total height of the knights used to chop off the dragon heads? There are several ways to solve this problem, but we will illustrate one that is probably the easiest. This problem is a bipartite matching problem. This will be discussed more in detail in section 4.7.4 in the sense that we are required to match pair. So we are required to match pair certain knights to dragon heads in a maximal fashion. However, this problem can be solved greedily. Each dragon should be chopped off by a knight with the shortest height that is at least as tall as the diameter of the dragon's head. However, the input is given in an arbitrary order. If we sort both the list of the dragon head diameters and knight heights in big O of n log n plus m log m, we can use the following big of minimum of n comma n m to scan the to scan big of minimum of n comma m scan to determine the answer. This is yet another example where solving the input can help produce the required greedy strategy. Yeah, and yes, this is the same as, let me check. Okay, so we'll be solving many greedy problems in this stream and the upcoming stream, which would be the evening. Yeah, I would come back in a second. Okay, so yeah, let me check if I'm still audible. We'll wait just for 10 or 50 seconds as there is a lag between stream and currently, the current time. Okay, so yeah, let me check if I'm still audible. We'll Okay, fantastic. I'm audible. So yeah, let's read the exercise 3.4.1.1. Which of the following set of coins, all in cents, are solvable using the greedy coin change algorithm discussed in the section? If the greedy algorithm fails on a certain set of coin denominations, determine the smallest counterexample V cents on which it fails to be optimal. Okay. Okay. Shall we read? Okay, see 51. We get these at the end of the book, right? These remarks. Duplicate tab and let's find 61. Hmm, what's going on? F2, F3. Yeah, F3. Uh, 51. Okay. A polynomial dial algorithm for the change speaking. David Pearson, a polynomial time algorithm. Let's check what this is. Okay, let me check. Let's check. Optimally making change representing a given value with the fewest coin from a set of denominations is in general anti-hard. In most real money systems, however, the greedy algorithm is optimal. We give a polynomial time algorithm to determine for a given coin system when whether the greedy algorithm is optimal. Okay, I actually don't know how to. I'm seeing this site for the first time myself. Okay, 231 to 234. That's what they are, I guess, trying to say. Okay, let's read what this is. A a polynomial time algorithm for the change making problem. Okay. Abstract. Optimally making change representing a given value with the fewest coins from a set of denominations is in general anti-hard. In most real money systems, however, the greedy algorithm is optimal. We give a polynomial time algorithm to determine for a given coin system whether the greedy algorithm is optimal. Introduction. In the change-making problem, we are given a finite set of coin denominations and an unlimited supply of coins in each denomination. We want to represent a given value with the fewest coin possible. The problem of determining the optimal representation is in general NP hard. However, in almost all coin systems, in use in the world, the problem can be efficiently solved by the greedy algorithm. This algorithm repeatedly takes the largest coin whose value is no larger than the remaining amount for general systems. The greedy algorithm is not always optimal. With the coin system 1, 3, and 4, for example, the value 6 will be represented by the greedy algorithm as 4 plus 1 1, but the optimal representation is 3 plus 3 uses one coin fewer. The English system in use before 1971, when decimal currency was introduced, was an example of natural coin system for which the greedy algorithm was not optimal. The coin denominations were in units of penny, half penny, one penny, three penny, six penny, 12 penny, shilling, 24 florin, 30 half crown, 60 crown, and 240 a pound. 48 pence would be represented as 30, 12, 6 by the greedy algorithm, while the minimal representation is 24 plus 24, which is 2 florins. The picture is further complicated by an obsolete coin, the guinea, with the value of 21 shillings. Yeah, we would like to determine for a given system whether the greedy algorithm always yields the optimal representation. This problem was studied by Chang and Gill, who gave a decision algorithm requiring time polynomial and the denomination of the largest coin and the number of coins, but potentially exponential in the size of input. Gave a more efficient algorithm, still polynomial in the largest denomination, and posed as an open problem whether there is true polynomial time algorithm for this problem. And this paper will be deriving in this we will derive such an algorithm which we first obtain a characterization of a small counter example if there is one for which the greedy algorithm is not possible. We then derive a set of big of n squared possible values where n is the number of coins which must contain the smallest counter example. Okay. Okay, yeah. So this gave us an idea of what is going on, of what the author wants to explain to us. But I don't think we have to get that much deep in order to understand CP. So as we will continue with our lives. Can S1, can S1 be solved using greedy? And my intuition says yes, but we will try to find a counter example. Okay. Okay. So this problem, I guess, can't be solved using greedy because let's say if our target was 19. So what would we do? Let's I will write this test case. 10 7 5 4 1. 10 7 5 4 1. And let's say our target is 19. Let's So what the greedy algorithm will do is it will take a 10. So yes, as the remaining amount 9 is greater than 10, we can't do anything. It will take 7. As the remaining amount is 2, we can't take 5, we can't take 4, we will take 1. So we will take 1 twice. But is this the optimal answer? And the answer is no, because uh, there is a condition uh, where using only 3 coins we can represent 19. So yes, this set uh, can't be solved using the optimal greedy. Let's talk about this set. I guess, yeah, I guess yes, this set can be used to. My intuition says I might be wrong again. So yes, it's just 64 divided by 2 until we get 1. Yeah, the set is 64, then 32, then 16, then 8, then 4, then 2, then 1. So can I think of any counter example? I'm not sure if this is the most optimal way of, tackling this question, but this is the only approach which I can think of, as this was also, at least suggested in the research paper which we are reading. So yeah, can I represent? I don't think there's any number. Um, no, I guess just by pure intuition, I guess this can be solved using greedy. Let's say I want to represent 8, then I can simply represent it. Let's say I want to represent 9, then I can simply use these two. I don't think that, yeah, I completely think that this can be solved using greedy. Um, 13, 11, 7, 5, 3, 2, 1. Let's say. Um, is there any counter example I can think of? 6, but it's not because 5 comma 1 and 3 comma 3. Okay, 7, no. 13, no. Let's say, how can I represent, let's say, 12? And the answer is 7 plus 5, which is 12. Okay, fantastic. Or 11 comma 1. Yeah, 11 comma 1. Yeah, indeed. Um, how do I represent 14? 13 comma 1. Yeah. I can't think of any counter example to this set as well. Uh, how do I represent 8? And the answer is 5 comma 3. Yeah, indeed, indeed. Or 7 comma 1. No, not 5 comma 3. Using greedy algorithm, it will be, 7 comma 1. And I pretty much think, yeah, this can be solved using greedy optimal as well. There are only two sets as of now. 7, 6, 5, 4, 3, 2, 1. Mm-hmm. How do I represent 7 by the number 7 itself? How do I represent, yeah. Okay, so how do I represent? I can represent 7 with the minimum number of coins. I can represent 6 with the minimum number of coins. I can represent 5 with the minimum number of coins. I can represent 4 with the minimum 4, 3, 2, 1. Let's say I get 7 x plus something. And now this number would be smaller than 7. And as we have figured out that we can use, all of these coins. Yeah, it's let's say I get a number, let's say 22. So I'll first divide this by 7. So we'll get 7 into 3. And then this remainder, let's say this remainder r, let's call this x. This remainder r should be smaller than 7, and we can use these coins. So yeah, we can indeed, use this for, we can indeed use this, we can indeed use greedy algorithm on this set. Let's check. 21, 17, 11, 10, 1. So, yeah, we are live. So, can we think of any counter example? Yeah, the counter example is 20. What the greedy algorithm will do is greedy algorithm will take 17 and then take 3 and then take 1 thrice. The actual, so the number of coins required is 4. But the actual answer is n comma 10, which is 20. And we need 2 coins. So yeah, this set cannot be solved using a greedy strategy. Let's read the remarks about greedy algorithm in programming contests. In this section, we have discussed 3 classical problems solvable using greedy algorithms: coin change, the special case, load balancing, the interval covering. For these classical problems, it is helpful to memorize their solutions. For this case, ignore that we have said earlier in this chapter about not relying too much on memorization. We have also discussed an important problem-solving strategy using usually applicable to greedy problem, sorting the input data to elucidate hidden greedy strategies. There are two other classical examples of greedy algorithms. Example: Kruskal-Simprem's algorithm for the minimum span tree (MST) problem. See section 4.3, and Dijkstra's algorithm for single source shortest path. Yeah. There are many more greedy algorithms, and that we have chosen not to discuss in this book. So, so they are too problem specific and rarely appear in programming contests, fractional knapsack, and some job scheduling problems, etc. Okay. However, today's programming contests, both ICBC and IOI, rarely involve the purely canonical versions of these classical problems. Using greedy algorithms to attack a non-classical problem is usually risky. Yeah. A greedy algorithm will normally not encounter the TLE response, as it is often lightweight, but instead tends to obtain WA verdicts, proving that a certain non-classical problem has optimal substructure and greedy property during contest time may be difficult or time-consuming. So a competitive programmer should usually use the rule of thumb. If the input size is small enough to accommodate the time complexity of either complete search or dynamic programming approaches, uh, then use these approaches, as both will ensure a correct answer. Only use the greedy algorithm if the input size given in the problem statement are too large, even for the best complete search or DP algorithm. Having said that, having said that, it is increasingly true that the problem authors try to set the bounds of these problems that allow for greedy strategies to be in an ambiguous range, so that the contestants cannot use the input size quickly to determine the required algorithm. We have to remark that it is quite challenging to come up with new non-classical greedy problems. Yeah. Therefore, the number of such novel greedy problems used in competitive programming is lower than that of complete search dynamic programming problems. Yeah. Programming exercises, most hints are omitted to keep the problem challenging. Fantastic. Yeah. Okay, classical usually easier. So let's solve these problems. 410 station balance. Yeah. Station balance. The International Space Station contains many centrifuges and its labs. Each centrifuge will have some C number of chambers, each of which can obtain 0, 1, or 2 specimens. Okay. You are to write a program which assign all S specimens to the chambers such that no chamber contains more than 2 specimens. And the following expression imbalance is minimized. Imbalance is equal to yeah. Where CMI is the chamber mass of chamber I and is computed by summing the masses of the specimens assigned to the chamber I. AM is the average mass of the chambers and is computed by dividing the sum of the masses of all specimens by the number of the chambers. Okay. Okay. Yes. Input to this program will be a file with multiple sets of input. The first line of each set will contain two numbers. Uh, the first number being C, which is in the range 1 to 5, defines the number of chambers in the centrifuge, and the second number S, which belongs in the range 1 to 2C, defines the number of specimens in the input set. The second line of the input will contain S integers will contain as integers representing the masses of the specimen in the set. Each specimen mass will be between 1 and 1000 and will be delimited by the beginning or the end of the line one or more blanks. Okay. For each input set, you are to print a line specifying the set number starting with 1 in the format s hash x, where x is the set number. The next n lines will contain the chamber number in column 1. Okay. Okay, so we have to, first of all, I guess, yeah. So what's the usual approach? Okay, so we have to, our main approach is to, keep two specimens um in each of the chamber, and the height of the specimen or the weight of the specimen should be as close to the average. So let's say I have to select two specimens to keep in a certain chamber. So what I should certainly do is, I have discussed this in the previous stream as well. We have to take a specimen which is the lightest and specimen which is the heaviest as of now, which is available at our disposal. And yeah, that is it. So if I say, just a second. So yeah, if I say the let's take this input 2 comma 3 and 6 comma 3 comma 8 is our input. 2 comma 3 and 6 3 8. So we have two chambers and we have to put three specimens in this chamber. So one thing which we will do is, first of all, sort this chamber in order to get easily the maximum and the minimum specimens at our disposal, but we'll add a 0 in the beginning. Now you'll understand why. Because ah, because we have to keep uh, we need uh we need a representation of sorts to uh actually represent four specimens, not three. Even though we have three specimens, but I can say that there is one more specimen which is of mass 0. So this will help us to pair the lightest and the heaviest. so that we won't be we it will be easier for us to do this. It's just a method of representation. That's it. You can also somehow figure out that I have to keep only eight over here, but eight plus zero makes sense. I'll programming and 3 comma 6. So what's the average weight? And the average weight is 17 by 2. And what is that weight? It is 8.5. And what's the difference between the uh, and what's the imbalance? And what is the imbalance? It is 17.5, not 17.5, sorry. 8.5 minus 8 plus 9 minus 8.5. And the answer will be 0.5 plus 0.5 and hence what? 1.00. Imbalance of your input should be printed to okay is 5 digits of precision to the right. Okay, fantastic. And I guess you have understood the assignment. Question number is 410 UV 410. Yeah, what's the last input? Yeah, they haven't given the last input. Vector and specimen 2 into n. Yeah, and the default value is 0, and then we'll take input for m specimens, which will be smaller than or equal to n, and yeah, specimen comma I, then we'll sort the specimen, then we have to find out these two things. Okay, let's just use double, or I guess we can use float. Okay, sum is equals to 0. Let's have int set is equals to 1. Set plus plus at the end. Okay, and here we are. If we need some gap, okay, is this a tab or is this just a blank space separated by exactly one blank? So we have set hash set, yeah, and here we will be having I equal to 0, I smaller than c, I plus plus. I smaller than not c, is smaller than n. Yeah, so I guess we are having a space over here. Then we'll print I, and yes, if um If specimen I is not equal to 0, we will print specimen I and followed by a blank space, and then we'll also print specimen of specimen dot size -1 minus I, and I guess there shouldn't be any blank space after that. So yeah, I will print, and yeah, float sum. Okay, sum plus specimen of I plus specimen or specimen dot size -1 minus I. Okay, yes. And what shall be the imbalance? The imbalance shall be sum divided by n. Printf imbalance 0.5 f imbalance. We will also have a new line, not a single new line. We'll be having two new lines. No, this is not the imbalance. This is average. Okay, my bad, my bad. This is average. We will be having float imbalance is equals to 0. Then we'll be again absolute difference between specimen of I plus specimen of -1 minus I minus the average. And then we'll print. One thing which I have forgot to do is that there needs to be a colon. One thing which should be blank folder. Okay. Set 1, set 2. I guess this is indeed the correct answer. Let's try to submit this problem. I guess there will be a P, most probably. WA, okay. We got it. Okay, I guess this this is something to do with. Okay. one thing if set is not equal to 1. Mm, Not over here. I guess over here. I hope that this shouldn't be the case. Should we? Should it? These P errors are actually so jarring because I'm completely aware of the fact that now are they is the judge thinking that I have printed 8 and then 6 comma 3, but I'm somehow supposed to print 6 comma 3 first. Okay, so yeah, we have to somehow um minus 1 comma minus I is not equal to 0, then and then only we have to print. I guess this was indeed an error from our side. And just for the sake of simplicity, I'm going to iterate from n minus 1 till I is greater than equal to 0. But now, now we have 6 comma 3 as they have given us. We have 8, we have n balance, we have 27, 33 comma 14 and 51. Okay, I guess this shouldn't hurt. I guess we have indeed, spotted a bug which was there. It was a genuine error and not a presentation error, I think. Let's see if we will get an AC. And okay, this is taking some time. Hmm, We got it WA. Okay, I guess we shouldn't do this circus. This n minus 1 ka circus. Yeah. 11.6. Let me just check if 11.6 followed by 4 zeros. 11.6 followed by 4 zeros. Yeah, indeed. Now these, okay, let me read the output. Okay, for each input set, you are to print a line specifying the set number, starting with 1 in the format set hash x, where x is the set number. On the next three lines will contain the chamber number in column 1, a colon in chamber column number 2, and then the name of the specimens your program has been assigned to the chamber starting in the column 4. The masses in your output should be separated by exactly one blank. Your program then should print imbalance equal to x on the line on the line by itself, where x is the completed. Okay, what I think it is that we have to set a width. I guess, yeah. I have to set a width for set w of 2. Sorry, let's try to submit this code. Please give me a WA if it is, quickly, so that I can move forward. What is going on? Oh, fantastic, man! I didn't. Okay, okay. I submitted 70 to 79 seconds ago. Okay, let's just wait. Till then, we will check what's the next problem. It is radar installation. Okay, did you get an AC? Shall we check his runtime? Nah, I have to check his code. Okay, yes, we did get a wrong answer. I guess the only reason being, let's just Let's just not care about this at W. Firstly, I think that this is still a presentation error because I can't find a flaw in this logic because indeed we have solved this exact same problem. Yeah, this is the exact same problem. We will just, search this problem on ChatGPT, and if we didn't get a clear answer to the, cause of the error, then simply move on because we have understood the logic, and this actually is pretty old book. So, yeah, presentation error and everything are not a huge thing as it was back in the time. So yeah, this problem and my attempted solution. No extra spaces after colon, is it? I can what? No extra space before colon. Um, can cause precision issues. Okay, yeah, I guess, yeah. We'll use double for each and everything. Let's check if we get an AC. If we don't get an AC, if even after this tweak, then mostly it's an presentation error or spacing and everything. Yeah, this is my output. Mm, Okay. Okay. According to the FAPS, FABS, you have to include CMAT. Okay. The logic is correct. The real bug is here. Okay. We need to use the FABS function. Fabs, not FABS. Okay, and let's check if we get an AC. If we still won't get an AC, then I guess 99% it's a formatting issue. Yeah, it's indeed a formatting issue. We have cracked the code, and we won't be wasting our time on this formatting gimmicks, I should say. Yes, radar installation 1193. 1193. Radar installation. Okay, so yeah, guys, what I was thinking of was that I guess today we will keep a small aim. Not small, I should say. It's a pretty sizable aim. We'll aim for solving 20 greedy problems today. Yeah, that's our aim. And yeah, let's keep this aim. We will not end our stream until and unless we have solved 20 out of 25 greedy problems. Uh, let's keep the rules as I can solve the problems from either UVA or Elite Code or Code Forces. Yeah. After solving this bunch of 25 problems, I guess we'll be good to go to the next topic, which would be dynamic programming. But I think I won't be, uh, uh, you know, um, studying dynamic programming next, because it's pretty heavy topic, and I'm not capable enough yet to solve, at least till C or D for Div 2 in Core Forces. So I have still time to learn dynamic programming, and I will focus on concepts like mathematics. I'll focus on concepts which are basic in nature, but important if not understood quite well. So yeah, so this is the aim. Here we have 8 UVA problems, 8 and 15. So yeah, even if we reach till this, even if we solve these two sections, we're good to go. So yeah, the next question is radar installation. Okay. Assume the coasting is an infinite straight line. Land is in one side of the coasting, sea in the other. Each small island is a point locating in the seaside. And any radar installation locating on the coasting, okay, locating on this line, can only cover distance d. So an island in the sea can be covered by the radius of the installation. Okay, let me read this again. So an island in the sea can be covered by radius installation if the distance between them is at most d. Okay, we use Cartesian coordinate system. Defining the coasting is the x-axis. The seaside is above the x-axis and the land side below. Given the position of each island in the sea, okay, and given the distance of the coverage of the radar installation, your task is to write a program to find the minimal number of radar installations to cover all islands. Note that the position of an island is represented as x comma y. Okay, yeah, x comma y coordinates. Yeah, we need input. The input consists of several test cases. The first line of each case contains two integers n belonging in the range 1 to 1000 and d, where n is the number of islands in the sea and d is the distance, and these distance of coverage of the radar. Okay, yeah, this is great. This is fantastic. Uh, yeah. So this is followed by n lines, each containing two integers representing the coordinate of position of each island. Then the blank line follows for the other test cases. Okay. Okay, this is an interesting problem. We will go back in our journal and try to understand what's going on. So, yeah, what's the test case? 3 comma 2, 1 comma 2 minus 3 comma 1 and 2 comma 1. So yes, this is our coordinate axis. We'll be having 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4. Means no solution for the test case. Okay. So first of all, okay, let's just plot these points. So 1 comma 2, 1. So yeah, 1 comma 2. So here is an island. Minus 3 comma 1. So yeah, here is another island, and 2 comma 1. Here is yet another island. And what's the uh, coverage of a radar? The coverage of a radar is D, which is equal to 2. So I need to somehow find out if okay, let me think a bit. One thing which is for sure is that when the coverage, when a y coordinate is uh, greater than the coverage, then I can't, keep it in the range of the radar. So yeah, this question is pretty interesting, I should say. Let's draw a circle. Okay, so if we keep this one circle would look something like this. Other circle would look 17. Assume that assume that this island is just on the edge. Okay, this island is in the circle. What I mean by that is that there's a circle at so yeah, okay, so as I have seen actually the output, it's 2, but I can't prove how can an output be 2. The question feels to be dynamic. Okay, so I have to cover. Okay, so one thing which is for sure is that if uh if none of the satellites in the fall, if none of the satellites' y coordinate is greater than the coverage d, then then we can for sure um include this. Okay, so I guess then we can for sure include. mm, okay, yeah. Yes, let's say there are n satellites, then let's say there are n islands, so and none of the islands fall exceed the boundary, so we can use n radars to cover the satellites, but we have to find out the minimum. So how do I ensure that let's say I am including the speed to satellite. Yeah, I'm including the speed to satellite in my radar, and I also wish to include some more satellites. Let's say I will try to include P1 satellite as well. How do I ensure that? This question is indeed a bit challenging. Let me think for 5-10 minutes. I'm thinking out aloud, so you won't be bored. How do I include as many islands? How do I try to include multiple islands using a single radar? This is interesting. As you know, they have added a constraint um, of y coordinate of the island. If what can you say? If all the islands would have been on a particular y coordinate, particular constant y coordinate, then it would have been pretty easy. But so can I say one thing that let's say I'm talking about let's say I wish to uh, let's say satellite PX island PX is not covered uh, in the radar, so I will include it, but I will keep it at the edge of the island. So it will somehow make sure. Am I bugging or will is this correct? Let me think a bit. Okay, so one thing which is for sure is that we will sort the islands as per the what can I say? We'll sort the islands as per the x-axis, as per their x coordinates. After sorting the x coordinates, we'll take first satellite and we will draw a radar, and then we'll check if all of the satellites can be are covered in the coverage, D coverage. If anyone's satellite is, you know, if anyone's satellite is impossible to cover in this radar, then we'll simply return -1. But let's say this is not the case, then we will first of all mm, include we will yeah, we will include the first satellite. We will include the first island using the radar which we have. But our aim should be to include some other satellite as well. Yeah. How do I ensure this? Guys, I know I'm taking my sweet time. Uh, this is indeed needed. Hmm. How do I, ensure that maximum satellites, or sorry, not satellites, maximum islands will be included in a radar coverage? Um, what are the edge cases which I can think of? Not I shouldn't say edge cases. But what are the cases which I can think of which are kind of unique and which are important? Okay, so one thing which I was thinking of is that Okay. So yeah, one thing which I was thinking of is that let's say let's say I have a point. Let me draw some extra points. Let's say I have a point over here. Yeah. So what I would like to do is I would like to include, let's say this is my center. I would like to include it in a circle at the edge. So it just gave me a feeling that I am including I have more scope to include the future islands. But the thing is, um, how do I explain it, guys? I really can't understand. Let's say this is our circle and this is the peak point. This is the peak. Let's say I have an island over here and there's there's the next island which is at the peak, which have the y coordinate as, let's say this is x plus something, x plus k, and it has y coordinate, and the coordinates of this point are x comma y dash. So including this, so including this island, by keeping it at the edge of the radar isn't feasible because I have to include the next island, and this both of these islands can be indeed included if I draw a circle which looks somewhat like this. Not exactly, but yeah. Yeah. Are you getting me, guys? I know the circle is not huge, as doesn't have, but you get what I mean. Let's this is a uh, you know what I mean. This is the topmost point of the circle. So I can think of two conditions, two or three conditions. Let's say, mm, I know I'm going to use a lot of pages today. Let's say there's this point and there's I can think of a few points, not points, I can think of a few conditions. Yeah. Okay, so let's say I have an island. Let's say the coordinates are x comma y, and I have the next island as x dash comma y dash. But one thing which you can see is y dash is greater than y dash is greater than y, and x dash is greater than x, isn't it? So the next island, mhm, I can't think of a solution, man. This question is really, really frustrating. I can do one thing. I can draw multiple circles. Okay. I guess I have converted. Yeah. I guess I understand what I'm doing. It's a sprinkler problem. Oh my goodness. Oh my goodness. Yeah. Assuming that we can cover all the islands. What the hell, man? Okay, yeah. I guess hear me out. Okay, let me draw a few circles. This is the same sprinkler problem which we have discussed. Yeah. Okay. And these are the islands. Let me draw, let me draw another circle. Yeah. Um. Even is this correct? I'm not sure. Then we can, eliminate some circles. As you can see, this circle and this circle. Assume that, this island is at this border of this interval. Then we can eliminate these two circles and I can say that, n minus 2 will be the minimum number of radars required. Okay. So let me explain you the greedy approach. Yeah. Here is our coordinate axis. Wow, what's going on, man? My goodness. Yeah, this is the coordinate axis. And let's assume that there are some points. As of now, we'll focus on, let's say, this point. Point or island. Yeah, you know what I mean. So yeah. Um. Okay, so this is the circle, and assume that this point is at the top. So yeah. So we will draw circles. Let's say this is at x comma y. We will not draw these. Okay, okay. Are you getting what I'm doing? Okay, so let's say the coverage is 3. So we'll have massive circles. Let's say there's a point x comma y. We will have a circle whose center is at x comma 0. And we'll do the same for x1, x2, dot dot dot, xn. So we'll be having multiple circles. But here's one thing. Here's one thing, guys. Let's say I drew a circle, which is this. And let's say this is the island which we are talking about. And there's this island, and we drew this. But I can let's say this is. But I can somehow include both of these islands if I draw these. This looks like a koala, doesn't it? I wanna just saying out my intrusive thoughts aloud. Yeah, I can include both of these islands by drawing a single circle. I need to somehow understand what preserves future feasibility as we are solving 3D problems. What provides future feasibility? This approach which I was thinking of was completely bollocks. One thing which I can think of is the condition. Let's say there are 2 points x comma y dash, where y dash is smaller than y. Then we have to draw a circle of the same coverage which we are talking about, and this will include both of this circle, and this will include both of the coordinates. But let's say if I keep this point at the edge, I should say, or at the boundary of the circle, then we are failing to provide. Then we miss the opportunity to provide this coordinate as well. I can't. I guess this might be right. Let's say I have a point whose coordinate is x comma y. The center of the circle is x dash comma y dash. I Okay, let me just erase this part a bit. This is radius r, or I should say coverage d, and I have to somehow figure out. Okay, this is not y dash, this is 0. So I know this is y, this is d. So I can find out x. So I can find out this. Let's call it let's call it k. So I, by Pythagoras theorem, I can say there was a girl. D square minus y square. Yeah, and x dash will be x plus k. And now we will continue the iteration if the next points, yeah, if there are any other points which can indeed be included in this range. Let's say y equal to d, k will be 0. Yeah, I guess yeah, this is the condition. Okay, can I provide any counter examples where this is not true? Let me think a bit. Okay, so what am I proposing? My proposed solution is that if, let's say, uh, there's an island remaining which is not covered in any of the radar yet, then the best thing which I can do is cover it such that this island is cover it if this island is cover it such that this island is at the boundary of the circle, and this island should lay in the left part of the circle, so that I'm ensuring. Yeah, and one more thing, if any other island and one more thing, if there exists an island which has x coordinates smaller than this island which I'm talking about, then this island is covered during the iteration. And all the islands which have the coordinate which have the x coordinate greater than equal to x have not been covered yet. So yeah, we are iterating from left to right. As you can see that we can calculate the x coordinate of the circle. What am I proposing is that it should be at the boundary of the circle or the boundary of the range. The only exception which I can think of is that, let's say, after sorting, there are. No, this is not an exception. This is a case which we should be, careful about. I guess this won't work. This won't work as well, I guess. Let me draw this at draw.io. I guess we can delete. Yes, we can draw a circle. Yeah, we can also draw let's represent it with a time. Let's say, I guess let's increase the size of the circle, and let's say, okay, so what we are, what is going on? Yeah, yeah. I have to, what my aim is that I should keep the island at the edge. Yeah, that's what I'm trying to do. Let's say if let's say the next island is at a is at has its y coordinate which is greater than this island. So we are missing out on this test case because this circle includes both, and the circle which we are trying to draw is this. So we are missing out on this test case. Are you getting me, guys? The distance. Okay, yeah. One thing which I can say is that, okay, guys, let me think a bit. What can be? Can't I draw an arrow? Yeah, I can. What is this? Oh, can't I draw a single straight line using this app? Yeah. Okay, so let's this point is over here and this point is, yeah. So this is the center and I have to, find out the maximum and minimum value of x dash. So one thing which is for sure is that, okay, guys, I get it. Guys, I get it. Okay. So yeah, this is the maximum value and let's duplicate it. Yeah. So this is the maximum and okay. I guess I get it now. I can think of some sort of interval. So the value of x dash can be, okay, guys, I guess I got it. Mm-hmm. So the value of x dash can range in the range of x plus k and x minus k. Are you guys getting me? Yeah, I guess we have found out some sort of interval which is, mentioned in the hint. Okay. Mm-hmm. Because I got some sort of interval, and you know, um, I can choose any of the. Okay, so the x dash can range in the can be in the range x plus k and x minus k to x plus k. Um, I have to find out an optimal value which includes most of the islands. Okay, how do I translate it into mathematics? Okay, x dash can be in the range of x minus k and x plus k. We have to find out a point. Okay, guys, I got it, guys, I got it. So, there will be multiple, okay, this is indeed an interesting question as well. So, hear me out. This is a non-overlapping question. Okay, I will explain you what I mean by that. Let me draw everything again. So, here we are, guys. Yeah, so this is our, yeah. So each and every point, let's draw this smiley shapes. So, uh, so, so each and every point will have their own set of intervals. Are you getting me, guys? And let's say the interval of this will be higher. Oh, my bad. This will have a larger interval. So we have to cover all the regions. Are you getting me, guys? We have to cover all the regions. So this is indeed a continuous interval problem where I can include this. Let's say if I find any overlapping interval, then I would just not, consider this. If I find any overlapping interval, then I can simply, you know, delete these. So what I can say is that using only three lines or three intervals. Okay, guys, just wait a second, guys. This is such an interesting question, guys. Okay, yeah. So let's say this is an island, this is an island, this is an island, this is an island. So they will have their set of valid intervals which can have the uh, have the x-axis as these are the intervals. Okay, what do these intervals mean? So I can draw a circle of d coverage on using this as the center, this as the center, this point, and each and every point as the center of and each and every point which lies in this interval can be the center of the circle which has a coverage d, isn't it? Let's say this starting let's say there's another interval whose starting point is smaller than this ending point. Then then we will consider the interval which has a farthermost ending point, because it will cover more circles, isn't it? Oh, not circles, but no more islands. So we won't be drawing our circle here. I guess I can draw a dotted line. Yeah. So we will be drawing a circle -1. We won't be drawing over here. -1 here as well, because we'll be because we have. No. I guess no, I'm messing up. I'm messing something up. I can draw a circle. Okay, guys, I got excited for a bit. Haven't understood completely yet, but let's say I have to draw. Okay, this is still interesting. One thing which I figured out is that there are certain intervals. Okay, now we will just think purely in terms of intervals. Yeah, we'll be thinking only and only in terms of intervals. Let's say this is an interval. This is an interval. This is an interval. So let's say at okay, so one thing which is for sure is that if I draw a circle at this point, I can cover three three ranges, I should say. So this and this. So I will be using only one radar for these three islands, and then I will completely jump to this point, and I will check if there is a starting point of a radar which has which is smaller than the ending point of this. I can see that this is on the range, so I can group this in one radar. So the answer as of now is 2, and I can group these two as well in one. So the answer will be 3. So for covering 1, 2, 3, 4, 5, 6, 7, for covering 3 islands, I can use 3 what can we say, radars. So what's the difference? So what's the difference between the previous interval problems which we have solved and this one? The difference which I can think of is that we have to actually group them. We have to group the overlapping intervals, and uh, we have to make them one. But make them one is not a correct. Yeah, you know what I mean. You have to let's say there are some overlapping intervals, so we can draw a single radar. For this, you know what I mean. We can use a single radar for covering all these intervals, and then we'll just skip all of these intervals together and then move on with the next interval, and then move on and try to find out the next bunch of islands. If a certain interval is not overlapping with any other interval, then we can, you know, draw the circle at any of the, what can we say, at any of the point which is valid in the interval, and yeah, we can go on with our lives. So I hope that you guys have understood the problem. If you have watched the yesterday's stream, it will be really helpful, as I won't be explaining the entire procedure now. Yesterday I had uploaded a video which is 1 hour long, and it's worth a watch. Yeah, so we had to find out the bunch of intervals, and as you know, said by the author, it's actually pretty useful if you have memorized, not exactly memorized, but you at least know how to find out a bunch of intervals. Yeah, a bunch of overlapping intervals. Yeah. So let's draw our circle again. This is x dash comma 0. This is x comma y. This is t. This is y. What can be the value of this? Let's call it k. And y range. Mm, yeah. And k can be under root of d square minus y square. Hence x dash can lie in the range x minus k if we are drawing this circle, and this is the d, y, and k. Yeah, you know what I mean. X minus k to x plus k. This is the interval, and then we'll find out the overlapping intervals. That's it. Now let's go through the input. Yeah. 1193. We'll take the input for n and d. Then we will vector pair end comma end positions. And then we'll take the input for yeah, each and every position. Yeah, let me check if. Okay, so the coordinate of each island. Okay. Okay, yeah, this is x comma y. X comma y. And then we have to write a function which returns pair of doubles. Let's call the function as get intervals, and it will take the input as the positions and the integer d. We will have another mm, um, yeah, calculate interval. We have done similar stuff in the previous stream, and yeah, we have to let me go through my notes. Okay, so double k is, I guess, let's assign everything as a double. Let's store everything as double. I know these are integers, but it's pretty safe to use everything as double. Square root. Okay, I haven't included CMath library. Yeah. So I have square root of. I haven't taken the input of double d. Yeah. Square root of d into d minus y into y, and simply return x minus k, x plus k. Okay. Shall we first check if we are getting the right intervals? Yeah. So vector pair double intervals, and it will be of size positions dot size intervals dot reserve positions dot size. Okay. Then we will iterate positions dot size I plus plus. Will iterate, and then we'll get not vector double comma double instant interval as calc interval x, not x, positions dot I dot first, positions dot I dot second, and d. In intervals dot pushback instant interval, and then we'll simply return intervals, and we will have one function as bool is possible. We will have vector of positions and int, not, this is double double d. If at any point positions that size I plus plus, if at any point uh, positions that I that second is greater than d itself, then we can't cover this uh, in our in using any of the radar. And yeah, as you can see here as well, if y is greater than d, then k will be an imaginary value. So we'll first handle this, and then we'll ensure, which will ensure that there won't be any case where y is greater than d. So return simply false. If none of these y coordinates are greater than d, then yeah, it's possible to include. First of all, we will say if is not possible, what the position, we will pass the positions, we will pass the double d. If not possible, then simply no solution. Okay, we'll simply -1. If it's not the case, then yeah, I guess we will also sort the intervals. So yeah, sort intervals dot begin, intervals dot end, and comparator function. I haven't intervals, not internal intervals dot end. I haven't declared the comparator function yet. Comparator function, I will have print double comma double, what shall we call it, position p1 double comma double p2 if return p1 dot first smaller than p2 dot first. Yeah, sort as increasing x coordinates. Okay, if yeah, first of all we'll print intervals. Yeah, we haven't got our intervals yet. Vector pair double comma double intervals, get intervals. We have position, we have t, and then we will why am I writing size dot second? Yeah, we will print a new line after every test case. Intervals, not internal. UVA1193. One more thing, if n equal to 0 and d equal to 0, I guess we have to break. UVA1193. Let's check. Yeah, for this point, We have the range of 1 comma 1 exactly as it should be. Exactly. Why? Because the y coordinate of this point P1 is equal to the average D. And I guess we are all right. Yeah, I guess we are all right. Minus 4 point. Yeah, we can draw a circle with this as the center, and we can draw a circle with minus 1 point. Yeah, fantastic as it should be. Yeah. Uh, yeah, we can. Yeah. Yes. Very good. Now we have to group int. Okay, we'll have group overlapping intervals. We will have pair double oof, as intervals. Okay, and we have to simply find out the overlapping intervals. Int count is equals to 0. Int ind is equals to 0 while ind is in the range intervals that size. We will continue to do so. Int ending point for this is intervals dot ind dot second, while ind is smaller than uh, intervals dot size and um intervals ind dot first is smaller than equal to ending point ind plus plus. Yeah, count plus plus and then simply return count. Let's not print anything. Um, group overlapping intervals, not get intervals. In okay, I have commented this in intervals. Yeah, we'll print a new line. 2 and 1. Okay, we have to also um, case number as 1, case number plus plus. I guess this will do. I'm pretty sure that this is there can be minor bugs here and there. Uh, okay, wrong answer. Shit. Let's check. Oh, I guess only here can be the problem. IND 0 ending point is IND or second. Okay, IND is more the interval size. We will find a bunch of overlapping intervals. Okay, fantastic. Okay, count plus plus. Have sorted the yeah, I have sorted. Okay. Sort as increasing x coordinates. Okay. We have got our intervals. That's amazing. Okay. Group overlapping intervals. We'll continue to do so until we find a starting point. We find an interval starting point is small, is let's say greater than the ending point. Until we find the starting point, until we find an interval starting point is greater than the ending point of the interval which we are discussing in the iteration. Is there a problem? Okay, 3 comma 2. Let me check. 312 minus 321 120200. Okay. What shall be wrong? Oh my goodness. This should be a double. This should be a double. My bad. Because yeah, interval is okay. Wrong answer again. Fantastic, but it's a different. Wrong answer. Yeah. Okay, we might be. No, no, we won't be stuck at a point. No, no, no. Okay, what is the edge case? What am I missing? So let's check our functions one by one is possible. Okay, we are iterating through the positions. If the y coordinate is greater than d, then we are returning false, else we are returning true. Okay, so if we are passing the positions, if it's not possible, then we are printing -1. Okay, and we are moving on. As I mentioned, we had to print -1. Yeah, -1 installation means no solution for the disk case. One line consists of the disk case number followed by a minimal number of the radar installations needed. -1 installation means no solutions for that case. A line of pair of zeros. Okay. Mm, yeah, I guess there's no issue over here. Let's check. Okay, is something wrong in my now? Double k equal to square root of d square minus y square, exactly as it should be. And comparator function sort as per. Let's just uh, print the first, then we'll print into I that second. Let's just print a new line here as well so that I can easily debug. Okay. No, I guess there's no need of this. I got minus 4732. Okay, let's just actually so what is the disk case? 1 comma 2 minus 3 comma 1 and 2 comma 1. So what is the value of k? K is in the range of d square. What's d? And d is equals to 2. So 2 square minus y, 2 square, and it is 0. So yeah, 1 comma 1, 1 comma 1. It's in the range of 1 comma 1. Let's try to find out the next value of k. It is d square, which is again 2 square minus 1 square, which is under root of 3. Okay, 1 minus, let's pull out our calculator. 1 minus under root of 3 is, so the range is minus 0.73, and 1 plus root of 3 is 2.73. Is this actually being printed? And the answer is no. No. My bad. Why am I adding it with 1? I should add it with minus 3. Okay, sorry, my bad. So minus 3 minus root of 3 minus 4.73, and is this being, yeah, minus. Let me erase this. Minus 4.73 and minus 3 plus under root of 3 is minus 1.267. Okay. The next value of k is under root of 2 square minus 1 square, which is again equal to under root of 3. So yeah, 2 minus under root of 3 is 0.26, and 2 plus under root of 3 is 3.73, and these overlap. Yeah, I guess, yeah, as of now, I can see that um the intervals are being printed correctly. The intervals are being what can I say? The intervals are correct. Okay. I guess, yeah, we are again facing this problem. Okay. When comparing two doubles, there can be a case where, um, the doubles are not actually being compared properly for equality. How do I, if two doubles are equal in C++? I know this is like the third time I am visiting this part again, but okay. Okay, let's just hope that this will work. 1e minus 6. Yeah. Or is equal. We'll have interval ind at first, comma, ending point, comma, 1e minus 6. Yeah. And let's see. Yeah. Are we comparing two doubles at any point? And the answer is no. Let's say and is not equal. Positions that I that second, comma d 1e minus 6. If they are equal, then let's just format our output again. We shouldn't be printing this. My bad. Okay, if okay, wrong answer again. Okay, so if entirely double ending point, interest is interest is smaller than double ending point. Okay. Double. If it's not possible, then simply print -1. Let's say just for fun, let's say assign it to point 3. It should print -1, shouldn't it? Yeah. Okay. Count plus plus if there's a case. Are we counting it in the right manner? Let's say I have grouped a bunch of these intervals, overlapping intervals together. Then count should be increased by 1, isn't it? Because yeah, that's is my group overlapping intervals wrong. Okay, so what am I doing in group overlapping intervals? Okay, so I'm first calculating the intervals given that none of the y coordinate of the island is greater than d. Then after calculating the intervals, um, I'm sorting them as per the you know starting points. Then I'm considering a starting point, and I am um, I'm checking how many other intervals are there whose starting point is smaller than the ending point, smaller than equal to the ending point. If yeah, then I'm grouping them in a single bunch. After grouping them, I'm incrementing the count. Yeah, this feels all right. Mm-hmm. Yeah, count should be an integer. Yeah, exactly. Let's ask ChatGPT if this function is right. Uh, good, this is nice. I didn't think it was okay. Okay, yeah. Ending point should be no. Ending point shouldn't be ending point shouldn't be updated, right? Oh, not chain overlap. I'm not talking about chain overlap. I'm talking about um directly. Yeah. AC for sample IO, but failing. This is the wrong problem. Why? For each element you computed an interval, place the minimum number of radars. So each interval covers at least each interval covers contains at least one radar. This is class A grouping. Okay, where logic code fails. Okay, all the intervals in a group can be covered by one point. Okay, but you never actually choose that point optimally. Correct gradient. After sorting, always place the radar at the rightmost point possible. Okay. Why? Sort intervals by ending point, not starting. Okay, pick first interval, place radar at its end. Okay, pick first interval, place skip all the intervals that this radar covers. Mm. Counter example to your approach. Okay. Why is it actually do? Why? You are grouping all overlap with 1 comma 10, one group. Okay, but minimum radius is equal to 2. How is this even possible? Sort by and maintain last radar position for each interval. If not covered, place new radar at its end. Intervals 1 comma 4. Place a radar at 3. Covers 1 comma 4. Okay, okay, just a second, just a second. I have messed something up. Okay, got it, guys, got it. I'm sorry, I'm saying this so passionately, but one thing which we are messing up is that let's see, yeah, this is the great counter example. We have to find a certain point which is common throughout the intervals. Now, our program as of now is grouping these. Okay, okay, my bad, my bad. So what a problem is actually doing is, let's say let's say the starting point of an interval is smaller than the ending point of the current grouping which I'm trying to do. But there's a catch, and the catch is, we are grouping these, but I'm not able to ensure. Okay, I'm not able to ensure how, I'm not ensuring that the intervals which are in the current group have actually, a common interval. Because let's say I have an interval 1 to 100, and now my program will include uh, the intervals 2 to 3, 5 to 10, 10 to 20, 30 to 40, 59 to 78. All these intervals under a single group. But choose a certain point which will cover all these intervals all at once? And the answer is no. So we have to find out. mm, yeah, we have to find out intervals which indeed have. Yeah, I have messed this up, guys. Thank you. Yeah. So, as per ChatGPT, we have to sort this as per the ending point. Okay, and I have to only care about the starting point. If I get okay. Okay, why do I have to? Okay, let me ask you a simple question. Why do I have to uh, sort this as per the ending point? And the answer is, l- I will keep all of my satellites towards the rightmost point. Why, you may ask? Because I have to, consider future feasibility. Let's say the current ending point is 2. The next ending point will be, let's say, 3. Now, let's say the starting point of this 3 is smaller than 2. Then I am, you know, then I have made sure that, the ending point is, the ending point is the ending point of the next interval is crossing the current ending point beforehand. And so this problem which I was talking about, that 2 comma 3 is being included in 1 comma 100, won't arise. Yeah. So I guess this is a mistake. I guess. um okay, I will check if this was the only thing. Yeah, I got an AC. This is the only thing which we are messing up. Yeah, sometimes. Yeah, yeah. This is kind of confusing. Yeah, but even I'm learning with you all, and yes, oh my goodness, why was I sorting the input according to the starting point? I should have, yeah. This was bad from me. I guess I can star these problems. Um, how do I, include these in the favorite? I guess, yeah. This is okay. Yes, I shouldn't be making the same mistake again. And yes, guys, yeah, that was my mistake. And yes, we have learned from our mistake, and we won't be repeating the same mistake for, calculating the overlapping interval. We have to sort according to the ending points and not the starting points. And this is the classic mistake which I guess I had done in the previous stream as well, and when I was practicing these questions by myself. So yeah, yeah, my bad. Yes, it was a wonderful solving session. I hope you guys enjoyed. And yes, I will be coming back in the evening, I guess, and we'll be solving some more questions. Yeah, it was a great day. I hope you all enjoyed. And yes,